Hello, hello. Hi, everyone. It sounds clear. Should I speak more loudly? Oh, perfect. Thanks. And welcome to our class, and welcome to the new semester. So we're gonna talk about engineering probability and statistics. The course number is CS 3130 or ECE 3530. So oh, by the way, is it look clear? Should I enlarge the font? Okay, let me enlarge it. Better now? Okay, perfect. Thanks. So thanks for joining this class. So I would like to first introduce myself. So my name is Shandian Zhe. This is my Chinese name, from which I was born. And I'm associate professor at School of Computing. So my specialization, is machine learning, artificial intelligence, data science, you name it. Anyway, it sounds like a buzzword to use artificial intelligence to tag myself. So just 5 years ago, I told everybody I'm a data science person, but now I'm gonna decorate myself as an artificial intelligence person. But anyway, this is just advertising. So I'm happy to have a chance to teach this class because that reminds me like about 15 years ago, no, about 20 years ago when I was a undergrad student, beginning to study basic concepts in probability and statistical tools, which brought a completely different view to this world. So later we'll talk about why should we care about probability and why this set of concepts and ideas and tools are so useful and necessary for everybody. So, so first, I would like to advocate our course website. Of course, everybody will get a notice from Canvas. I believe you're able to access that. But if you want to look for more comprehensive and up-to-date information, especially lectures and lecture videos, we highly suggest you to come to the course website. The link is provided in Canvas. If you go to the Canvas tab and there's the syllabus section, we got the entry to the course website. But if you can also search on my homepage and looking to the teaching section, you see this one. This link just indicates what the course I'm currently teaching. So if you click into that, it's just a very simple and concise website, but is comprehensive enough to include all the information. So schedule Tuesday, Thursday from 3:40 to 5 p.m., which might not be a very good time. But be sure not to get sleep in the class. Yeah. And this is a big class, right? It's a big classroom. And I think in addition to the course schedule, there's one most important schedule is about final exam. So the final exam is on Wednesday, April 30. Course is 2025. At the same class time and in person, unfortunately. In my previous classes, I usually want to schedule everything online. Like, so everybody, you don't need to come to the campus, you just sit in front of your laptop and at whatever place you feel comfortable, you do the exam. Unfortunately, this class is a little bit theoretical. We have to do this in-person class and we have to be close book. That's the only inconvenience that might bring you. And also we give a link to the official page. So if you click into that, it also explains why our final exam is scheduled this week. We just follow the rules of the campus administration. You can double check. Of course, this is also a link for you to double check your other exam schedule. Okay. Oh, by the way, I would love to interact with everyone. So if you got questions, just hands up or just ask, but speak loudly because this is so big classroom. So if you speak not loudly, I may not be able to hear your yeah. Okay. So instructor, of course, is me. And if you click this link, is go back to the home page and yeah. So this is my office, and this is also where I'm gonna have my office hours to do Q&A. And this is my email address. And we currently we have like 5 teaching assistant, and hopefully we'll get another 2 teaching assistant to help everyone. And here is the office hours. So my office hours just right after the class. So I mean, after the class, if you want to have some problems, want me to clarify or additional help, you can talk with me here or go back to my office and ask whatever. That will be very convenient. Or we can walk together to my office. But in addition to that, every TA will provide additional office hours. And to be convenient, we intentionally schedule an office hour for every weekday, so that we don't want like everyone to rush into the office hours at the end of at the deadline. Right? That's not very efficient. So we try to split the office hours equally every weekday, so that to make sure that okay, when you enter the office hours, you won't feel like too crowded. But we'll release the detailed schedule later today. I will also post it on Canvas. And sometimes the TAs might have their own issues. They cannot come to the office, TA office in person, but they're gonna post the Zoom link, and you can log into Zoom link and talk to the TA. I mean, many cases from the feedback of my other classes, students feel like, okay, this might be even more efficient. Okay. Okay. So our major task for this very first class is not to talk about details, math and stuff. We're gonna mainly walk through the syllabus to ensure like everyone is comprehensively informed. If it is you feel very boring, you can do whatever you want. Right? So, but to make sure like okay, everyone feels comfortable and informed for the course content, we have to spend a little bit of time to walk through this. So please bear with me. Okay, so this in this syllabus, it also like summarize what we'll cover in this course, what is policy, grading policy, and how we're gonna give the final letter grade for everyone. Right? So it will be a good policy document for you to review. If you're not sure, like eventually you're gonna which kind of grade you're gonna get, or what kind of things you can do for this class, what kind of things can I do, right? So of course, this is like very first section is about the link to the course page to make sure like everything is connected. We have our 5 teaching assistants, teaching assistants right now, and office hours, and we just put the link office hours to avoid confusion. Right? Okay, so what this course basically is, right? So here we want to give a very. Oh, by the way, is it clear to everyone? Should I enlarge the font? Okay. Okay, thank you. So what is this course about? Very concisely, this course provides a calculus-based introduction to probability and statistics. So what does mean by calculus-based? It just means it's a little bit serious course, meaning that we're just not talking about ideally verbally. Right? We want to do some kind of mathematical notations, definitions. We'll also do some kind of inference, meaning that you have to prove something or calculate something to be quite rigorous. Right? So we intend to cover some kind of fundamental concepts and computational methods in probability and statistics. The aim is to prepare everyone for careers in the engineering and science domain. Like, for example, electrical engineering, communication, computer science, data science, software development, machine learning, artificial intelligence, and so on. Those concepts or methodologies are so fundamental that in the future, if you do anything regarding engineering or scientific research, or even some kind of like survey study, you cannot escape it. You have to leverage those concepts and do proper, calculation, analysis, and so on. So this is very important. But don't worry, it's not very difficult. As long as you have passed calculus, this it's not very hard, but you do need to take some time, understand ideas, and do some kind of practice. Right? It's a little bit boring, but this is how you study math, right? Okay, what kind of reference books, right? So we're gonna have a major textbook. This is called A Modern Introduction to Probability and Statistics course, Understanding Why and How. Also a very good, is very well-written book, and for students in any background, as long as you know basic calculus, it's very easy to read and provides tons of live examples and interesting examples for you to understand why those probability concepts are important and how they are leveraged in practice. Right? So and the good thing is that this book can be accessed online. So give this a secret link. If you cannot download it, just let me know. I'll give you the electrical version. Right? But right now, I tested it yesterday, still workable. So just download it. And if you feel like this book is not deep enough or is not rich enough, we also recommend another book, which I use this book for my graduate study. Yeah, maybe 12 years ago. Right? That book is a little bit broader and more in depth. If you're interested, you can download that as well. It's also free online. Feel free to download and read it. Right? So we will see that as the lecture goes on, right? So we're not only talking about things like in slides, doing practice on whiteboard, but also we will recommend you guys to read through several chapters in this textbook to strengthen your understanding and also to absorb more examples, because the time is limited. We would love to give you as many examples as possible, but we cannot always give examples. We have to proceed. So in that context, like if you want to learn more, you want to do more practice to feel like more concrete, you can. That's why we recommend you guys to read through several chapters. Okay, so here's the prerequisites for this class. So it's kind of pretty lengthy conditions. Well, but we can summarize. It can be summarized in one sentence. We do expect you to understand basic calculus, because those definitions like random variables, expectation, covariance, they are all essentially based on calculus. We have to do some integration, right? But again, if you feel difficult in some kind of basic concepts, just let us know. Right? We can help you to walk through these topics, all the topics there. Okay, so how would we help everyone in this class, right? So we will highly encourage our students to take advantage of the office hours, right? As we just mentioned, right? We intentionally allocate TA office hours for every weekday. I myself have office hours on my lecture day, and also we'll monitor the Canvas Q&A sessions. So please do not be shy. If you have any questions, just ask. Right? And if you don't know how to work out problems, bring the problems to the office hours, discuss with TAs, right? So that would be very efficient because everyone is multitaskers, right? If you don't know everything, like you start to work out from scratch and spend a lot of time doing that, it's not worth it, right? Just try to seek help. There's just one thing which is not encouraged, is that if you guys are talking through Canvas and don't list the potential answers, right? Not like Stack Overflow, right? Some QA website, you say, okay, I don't know this problem, and some nice guy will just give you step-by-step approach. Is just copy and paste. That's not allowed. So we'll just monitor the Q&A. Like you can discuss what kind of ideas, what kind of directions might be helpful to solve the problems, but just don't put step-by-step answers, right? That's not. We must make sure like everyone will write out their answers by themselves. Okay, any questions so far? Okay, perfect. So what kind of topics we probably will cover, right? So here we list a tentative list of the topics we'd like to discuss, right? It seems a lot, but is they're tightly connected. It's likely that, okay, we're gonna cover several items together in 1 or 2 lectures, right? So we're gonna start introduce the basic concepts about probability. That means like, what does it mean for sample space? What does it mean for events or random events, right? So we'll talk about that later, but just to connect us from like empirical feeling, like this word is a word of uncertainty. Everything is uncertain. And then how can we build up some terms, some atomic terms to start describe this uncertainty in this word, right? You see that we're going to start with the so-called sample space and events. And based on the events, we're going to define the so-called probability function, which maps the events to a number between 0 and 1. That's the people call probability or chance or likelihood, this kind of stuff, right? And based upon that, we can define, okay, how do we represent events sets, right? How do we operate among the events, right? How do we construct new events out of old events, right? And when we construct new events, how can we calculate their probabilities? What's their relationship? So there comes like law of sets, even operations, probability density, conditional probability, Bayes rule, and those kind of stuff, right? So it's kind of like a systematic organization which can gradually convert our empirical sense about uncertainty and uncertain reasoning to some rigorous mathematical terms, definition, calculation, and inference. So it's kind of like a, gradual procedure, right? And then given this definition of probability density function, cumulative distribution function, we're going to introduce random variables and some very important properties of random variables, such as expectation, variance, covariance, correlations. Some of you might have heard that before, but never mind. We're going to quickly review them. And we're going to introduce several very important, but perhaps the most simplest distributions called Gaussian distribution. And bivariate Gaussian distribution, you see that the bivariate Gaussian distribution has a very nice form. And the very important concept called identically independent distribution, IID, and everybody should understand what's the meaning, because it's a foundation for nearly all the statistical inference method, because you see that nearly all the textbooks will say, okay, assume the data is IID, then we can estimate the mean of this distribution is blah, 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 the covariance is blah, 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 right? So we need to understand why they're going to assume IID assumptions, right? And we're going to also point out there's some kind of limitation. Not everything is IID, right? In our case, what kind of like consequence we will have, right? And we'll introduce like law of large numbers and central limit theory, which is very classical, discovered for 200 years or 300 years, but it's still like at the core position of the modern statistics, right? So the last part, we'd like to introduce a set of statistical tools. So you see that the difference between the probability and the statistics. Right? Probability is like tools. Probability is like theoretical tools. It gives you a bunch of terms and framework to describe or characterize things of uncertainty. And statistical is kind of application. It's about how to leverage those tools to address practical problems. Like for example, I would like to know tomorrow if I buy Tesla, right? What's the chance that I'm gonna win $100, right? So to address this problem, you're gonna leverage statistical tools, right? But when you leverage the statistical tools, you're gonna use basic concepts and framework inside probability theory, like random variables, like expectation, like covariance matrix, and all kinds of stuff. Right? So we'll give some like elementary introduction of the usage of these tools, like estimation, bias, unbiased estimate, confidence interval, hypothesis testing, and those kind of stuff. Right? And finally, if we still have time, probably we're going to introduce some like statistical model, which we're going to start with linear regression, which is very straightforward, very intuitive, but right now it's still like has a broad usage. Right? And in the future, if you're interested in doing like more advanced study in statistical learning, machine learning, you see that like neural networks or artificial neural networks, more than machine learning methods, they can all be viewed as some kind of like very complex generalization of linear regression. Okay, any question? Yes, basically I'll follow this order. So this one is like, so for example, if I talk Gaussian distribution, you have to introduce what does mean for what does mean for expectation, what does mean for variance, what does mean for covariance. Otherwise, we cannot talk about that. So basically, it's kind of like a thread of the concepts gradually introduce more and more advanced terms and concepts and so on. Any other question? Okay, so now let us talk about probably the most important thing, how we're gonna grade. Right. So basically we have 3 parts. The most important part is homework assignments. It takes 50% of importance. Okay? So you'll see that we'll have around 7 homework assignments. Don't worry, it's kind of frequent, right? But it's not very long. And as long as you can commit and can spend some time, there won't be any problem. So typically, we plan to release every homework assignment like twice a week, not twice a week, after every other week. Right? So usually you will have like 2 weeks to finish homework assignments, and 99.9% possible that the assignments will just be analytical problems. That means it's just like your calculus practice, right? We just give you problems and you solve it. You can do some manual solving and take a picture and upload to Canvas, or you can use LaTeX. Some of students love to use LaTeX. Of course, we work hard, but whatever is mainly about analytical problems. Make sure if you do manual writing, make sure it's clear. It's easy for TAs to recognize. Otherwise, if they deduct your points, you have to negotiate with them. Right? So wasting time. Right? There might be very light programming tasks, which is not about asking you to implement a super big thing. Probably we'll just ask you to plot some figures showing, say, samples of Gaussian distributions or samples from or calculate some estimate empirical estimate of the expectation of random variables, so on. It's very light. And if there is such a programming task, you're free to use whatever program language you feel good, right? So we recommend you use R, Python, or MATLAB, right? And through our class, to give you a better sense about this, statistical concepts or inference methods, how they're kind of working, we'll from time to time to show, to use some like Python, typical Python, to show how this is going on and project there. And we'll also share this code. And if you are interested, you can play around on this code, but it's not required. Okay, any question regarding homework assignments? I think it's just in general, it's just around 5 or 6. Yeah, but be careful, each question might be has some sub-questions. But usually we don't want you guys to be overwhelmed. But it's not a good strategy to start doing things like 2 hours before the deadline. That's not good. Other questions? Okay, great. Then we'll have some quizzes. So quizzes will be deployed on Canvas. Don't worry, quizzes are just single choices or multiple choices. Maybe just 5 single choices, multiple choices. And unfortunately, they will be quite frequently. Perhaps we'll just release it like weekly and just ask you to spend less than 10 minutes to finish. But don't forget to miss it. You miss some points. And later I mean, to account for some like, some students might just occasionally miss that. Probably we'll just schedule, say, 15 quizzes, but then pick up the top 10 or 12 such kind of quizzes as your final, which are counted into our final grade. But we'll let you guys know later about this schedule. Okay. So the last thing is a final exam. It takes about 30%. Again, because this is a kind of a theoretical course, we have to do some kind of a closed book and in-person final exam. Just make sure you don't miss it, right? And come and join the final exam. Yeah. So any question regarding the overall grading policy? What day of the quizzes and assignments? Okay, quizzes are usually released on, I mean, the due will be usually on Friday. Yeah, and homework assignments usually released on Tuesday or Tuesday night or Wednesday, and it will be usually due on, the Tuesday following that Tuesday, right? It's 2 weeks, right? So, but anyway, whenever we release the homework assignments and the quizzes, you will get notice from Canvas. So just make sure you don't miss Canvas announcements. Other questions? You can take it at whichever place you want, as there's no restriction. There's also, open book. You can use whatever tools to finish that. We're pretty much sure that the quiz is super simple. Just want to keep track everyone is on this class, right? It's just not like leave for a while, right? Just that it's not hard at all. Okay. No, we don't have midterms. You want midterm? Okay. Yeah, I guess no one would like to do midterms, right? Yeah. Again, the goal of this course is not to let everyone to be like a super expert in calculating complex probabilities. No, that's not the goal. The goal is to help everybody to know those very important fundamental concepts. Because later, when you dive into a specific area, you'll know that it will need a lot of like in-depth stuff, things, right? That relies on your basic understanding. We want to make sure everybody understands the concepts. We're not training to be a calculation expert. Other question? Okay, great. So letter grid mapping. So basically, this might be the standard way of doing this, right? You just round up your numerical score to the closest integer values. For example, if you got 90.5 to 90.9, I will treat this as 91. If it is 90.1 to 94, we treat it as 90. Right? It's just a rounding. Right? And then we will map your numerical grade to the letter grade following this table. At end of semester, like if you feel you got some points to be able to edit, for example, if you just need 0.5 to become A, not A minus, or become A minus, not B plus, feel free to come to me, and we can walk through your, your assignments and all stuff you have done, and see if we can find out some points to help you improve the grade. Right? But after that efforts, if there's nothing can change, and then you're where you are. Okay. Again, the final exam. Okay, late policy. So we request the every assignment be turned through Canvas by the designated deadline. Right? So we have nearly like every 2 weeks we have a homework assignment, and we intentionally make the homework problems to be concise, but not be too overwhelmed. So that means like we usually do not like doing some whole class extension. We hope you guys can turn in through Canvas in time. And however, if due to some various reasons you happen to submit lately, you might have some like a penalty. Like if there is some late submission, it will automatically incur 10% penalty. However, if the submissions is more than 24 hours, you might incur like an additional 10% penalty. And we usually do not, the close window will be, the submission window will be closed usually after 48 hours of this submission deadline. If you happen to have some like emergency, right? Like some illness, like you have to do, I'm not saying anything bad, but in case, right? If you happen to have some like emergent health issues, family issues, or hospitalization, accidents, so on, like you have to delay your submission, please let us know. Right? And again, to be fair to all the other students, please provide with us some documentation. We won't disseminate, just keep it as documentation to be fair to all the other students. There's one thing we cannot use it as a basis to do the extension. I mean, this happened to in my past experience. Like some students came to me and said, "Oh, hey, professor, I'm too busy. I have 3 other classes, I have 5 projects deadlines. Can you allow me to submit my homework assignment or project report like later and so on?" This is not a valid reason because every student is a multitasker. You guys are all very busy. And everyone is taking more than 1 class, I believe, right? So I cannot give you extension because you're busy doing other things, right? So really, if you want to, we can only consider the extension because of this, as we mentioned, like emergent health and family issues. Okay, any questions? Okay, so and also we'll try to push our teaching assistantship to grade the homework assignments as soon as possible. But sometimes because we have a large class, right? There may be some error, and if you feel the error, the grading has some error is not reasonable, you can request a regrading. But we have some like a time buffer. So please, when you receive the grade and within 1 week, if you find anything wrong, if you feel, okay, it's not fair, I should receive more points, or you're too generous, you should deduct my points. Just come to just send me an email. I will forward your request to the TAs. Does it sound good? Okay. Okay, homework submission. As we mentioned, right, we request everyone to submit your homework assignments through Canvas. That means we cannot accept papers. We do not forbid you from writing things on papers, but when you submit, do make sure like you scan. You can take a picture with your iPhone, or you can use whatever scanner and then upload to Canvas. And if you use LaTeX, you are more than welcome. Like if you use LaTeX, we recommend you using a well-known online LaTeX editor. You don't need to install any LaTeX editor. Just open the browser. You can do it freely. That's the most convenient one. And if we happen to have some light programming tasks, don't forget to attach your source code. In that case, our TA will also need to check your code. Okay, any questions so far? Code file is enough. If you want to do code repository, that'll be even good, because really no one is gonna do this, right? But yeah, of course, yeah. Oh, that's a good question. So it's not like entirely based on whether the final number you give. We're gonna look at the steps you use to tackle the problem, right? And if every step looks great and only you have like a minor calculation issue, that's not a problem. You might still get a full grade or a little bit reduction. But do not miss the intermediate steps. If you just put a number on it, you're very likely to get a large portion of points deducted. Because the reason is that we do want everybody to know, to understand this thing, that we do not require you to be a super expert in calculating things, right? We just want you to know every steps. We want to see the analysis. So, I mean, even for a problem you are not able to completely solve it, don't leave it as blank. Right? Try to write as many steps as you want, and you can think of. You will always get some grades. We're trying to be generous. Great question. Any question? Okay, great. Attending the final exam, we expect every one of you will be able to join the final exam on time. But we understand that some students might, have some like unexpected accidents or some other things might miss the final exam, right? So if you happen to miss the final exam, right, due to some emergency, please notify me within 3 days of the exam, so we can have some time to schedule some makeup exam. If you don't do that, it's not that will be problematic, because our school is always quite tight for us to like grade and give the final letter grade, and the time window is very short at the end of the semester. So if you just notify us like 2 weeks after the final exam, it's very likely your final grade has already been uploaded to registrar office. It's very hard. So yeah, if you happen to miss the final exam due to some emergency, we'll try to help you, but just let us know as soon as possible. Right? And there's another case that, okay, you probably have, you are unable to take some final exam at a scheduled time due to some reason. But by the way, you cannot say, okay, because I'm traveling, so I cannot take that. That's not a good reason for that. But if it is is a good reason, and it's a reasonable excuse that you have to find another time to take final exam. Please contact me ahead so we can try to schedule another time for you. Okay. Academic policy, this is just the standard. Don't cheat, right? And if you got cheat, that won't be good for you, right? So we should respect the policy, right? And one thing we want to talk about the collaboration policy. So cheating, I mean, we don't feel like you discuss with your fellows as a cheating. That's not at all. So actually, we encourage you guys to discuss the possible solutions for homework assignments or even quizzes, right? We just don't allow you guys to discuss during the final exam. Right? So, but the key is that you can discuss, no problem. You can even like write down things on whiteboard, and you guys will find a rich agreement about how to solve some problem. But the issue is that you have to write down the solutions by yourself. Right? You cannot just copy others. Right? And if your solutions tends to be exactly the same as the others, or just a minor difference, then that will be a problem. Then we have to, investigate whether this is called cheating. We hope we will never see such kind of cases, because we don't want to bring you in trouble. Right? Okay, so finally, if you have some physical challenges, you have some issues, just let us know. We'll try to accommodate you as much as possible. Okay, that's basically the quick walkthrough about the syllabus, course policy, etc. Any question? What? This one? You don't see the syllabus? Oh, really? Okay, yeah, I'll take a look. Yeah, because what I say is just 3130. Oh, probably I haven't merged them. Maybe they are two separate ideas, but I apologize for this. I'll make sure to have this. Oh, I didn't realize there are two course modules. Okay, I think thanks for reminder. Any other question? Yeah, it is recording right now. Yeah, I will talk about that when we walk through the course website. Okay, so this is about the syllabus. But again, the content is repeated and emphasized again on the website. So you can walk through everything here. It's basically almost the same as the syllabus. But the one thing I want to emphasize is this lecture tab. Right? You see that there's a table. It will be growing along with the semester goals, right? So we'll list lecture slides, and the chapter we recommend everyone to read, and also the lecture reading. So we try to every class I try to stream the video to some YouTube channel, and after that we'll just put the link there. So in case that sometimes you miss the class, or you have to miss the class, and you want to still watch the, or sometimes like you want to relook at those lectures. Okay. Any other questions? There's not like absolute, I mean, due or something like check. You must finish the reading. We just recommend to read that. So usually for chapter 1, probably just this week or early next week. Because chapter 1, we'll see that it's a very interesting chapter. It's just talking about how probability statistical things are used throughout our history. It's associated with many very important scientific or engineering breakthroughs, like even going to the moon or discovery of nuclear bounds or this kind of stuff. So that's why I highly recommend you guys to read through the book. But it's not like obligatory. You can choose not to read as you, if you feel comfortable. Other questions? Oh, yeah. So, yeah, good question. So here, the major or the primary textbook is this one, A Modern Introduction to Probability and Statistic Understanding. Yeah, this one is very friendly book. And we highly recommend everyone to read through it. I mean, at least read through the chapters we recommend, right? And for this one, it's more in depth. The book was written for graduate students. That's why it's just minor. If you have time, you're energetic about stuff, feel free to read that. It's not totally voluntary. Any other question? Okay, great. So now we're gonna start introducing. Okay, I'm gonna switch to the iPad to introduce a little bit concepts about probability. Just give me a second. Okay, so now we would like to uh, explain what probability and the statistics and why we should care about them. So what is probability? Probability is a branch of mathematical theory. So you can see basically view it as a kind of like a very rigorous way to describe rules that govern random events. Right? So, and then there comes a problem, right? So what do you mean by randomness? So what's the randomness? When we say, okay, the world is filled with randomness, chaos, everybody feels comfortable, right? It is the word, right? But how do we kind of rigorously or formally define randomness? Anyone? Uh-huh. Okay, that's one aspect to do that. Sounds good. And okay, yeah, that's a little bit more specific. We're talking about, okay, you talk about you're doing some kind of say experiment, but you don't know the outcome, right? Beforehand. And you're talking about there could be many possible outcomes, right? But you don't know which. Okay, that's great. Another sub. Okay, so that's a talk about how do you check if this is a real randomness, right? If you just repeatedly doing, you found like a very stable pattern, very determinist pattern, we look at as random, right? Yeah. Okay. That's very good. So we would like to summarize what you guys are talking about, right? So basically, what is randomness? Right? So the randomness comes from the uncertainty. The uncertainty means that if you do something, right, if you don't observe the results, you're not sure about the result. So it means that, okay, you don't know the result beforehand, right? And also it means that it could be many, many different results. Again, it's an unknown. And it could be that, okay, truly random means that you cannot crack it out by doing these experiments for 1 million times that you finally know, okay, it's actually in essence deterministic, right? So to be very concise, it's just saying like, we were talking about a random event. It's just an event for which we do not know the outcome without observing it. So when we observe it, we know, okay, what's the result, right? However, when you conduct this experiment again, before you observe the result, you still don't know the results. That's the randomness. So, and the probability theory tells us what can we say about such events, right? And of course, when we talk about some theory, we always give some assumptions, right? You see like under a lot of different assumptions and what kind of possible results will be. So probability theory is just the mathematical rules give us more rigorous and more serious characterism and calculation about those random events. Okay, so what is statistics? As we mentioned, right, the probability provide tools, mathematical tools. Right? It's like a hammer, it's like a whatever, vehicles, whatever, right? And statistics is about the application of these tools. Right? Statistics connect the theory to the reality. Right? So statistics is the application of the probability to collection, analysis, and the description of random data. So here are a few commonly scenarios where we apply statistics to, right? So we want to use statistics to design experiments. For example, you have developed a new vaccine, like mRNA vaccine, right, for COVID, or you have developed a cancer vaccine, right? How do you prove your vaccine or your cure is effective? Right? You have to design some kind of clinical trials, right? And that relates to how you're going to select the sample of the patients, right? How do you select the control group? How do you conduct observations during some kind of time, right? Sometimes you have to do some kind of this kind of experiments across different regions, across different time horizons, right? Those are based upon statistical methods. And statistics also used to summarize the data. So see that in this year, right, so the data is everywhere, and people have accumulated data. It's too much, right? No one can really read through the data from scratch. Right? It is stored in big disks or big tapes in big storage, right? So we'll never be able to go through all the data. Then in that case, if we want to still know the knowledge, if inside the data, we need some tools to extract this knowledge, or sometimes give you some kind of visualization. This is another important application of statistics. And draw conclusions about work. This is more like decision. Right? So given, for example, you're in an investment company, right? So given your profit from last year or from last 5 years or last 10 years, how are you going to make decision to invest stocks or funds or ETFs or whatever in the next year, right? You have to come out some like statistical model, analyze the risk and possible benefit, right? You have to find out the best possible outcomes based upon decision, right? Those are also based on statistical methods. Of course, statistical methods will leverage those theoretical concepts and tools in probability theory. And explore complex data. Again, going back to the data, right? Because data right now is everywhere in different areas and also across different regimes, right? And how do you build connection between data from different sources and in different heterogeneous format, and then extract useful knowledge, right, across different domains, right? Okay. So here we just list some kind of like exemplar areas which heavily rely on probability and statistics, such as machine learning, data mining, artificial intelligence, simulation, scientific simulation, image processing. For the electrical engineering, has to do with signal processing, information theory, computer theory, hardware, electronic testing, and so on. You name it. There's too many, right? I hope in the future you will dive into whatever specific area you will see the importance. Right? Some like concrete examples: gambling, right? Not recommended for everyone, but you want to be an expert for this, you'd better learn some statistics, right? Not just try with luck, right? If you're interested, you can see like blackjack, right? So actually, the computer program now can play much better than the world champion in blackjack, right? So this is totally based on statistics. Right? And stock market analysis, which we have analysis before. I have several friends working Wall Street and hedge fund. There's their whole life. Their goal is to look at the data and analyze them and to make the investing strategies to earn more money. And politics, that's something maybe is less aware. Actually, politics is also heavily relying on statistics. Right? And every time if you look at a poll, right, and actually no like those companies can really survey every residential in the United States, right? You have to do some kind of samples, and if you're not taking right samples, it's very likely your results, your conclusion is wrong, right? For example, last year's election, right? So it's yeah. Sports, right? This is also another very important area, and especially if you do some gambling regarding sports, right? This is even more important. Demographics and medicine, we have mentioned that before. Right? If you want to do clinical trials, right? And this is just one aspect. Actually, in all this, like many medical companies are trying to leverage big data and machine learning to help design medicine. Right? These are essentially, although it was decorated with very fancy names, but on the line is still statistics and probability. So basically, you can imagine like I have accumulated a large library of chemical molecules and their properties, and also experimental data, and even some kind of clinical trial data, past century, right? And then I want to develop some medicine to address some syndromes, right? I want to find out the right molecules. How do we design those molecules, right? Which is effectively targeting, where the illness or the corresponding body part without hurting anything, right? It's very hard problems. The traditional medicine developments is like a blind trial, like blind shooting, right? And it really depends a lot. But if you can smartly leverage big data, probability and statistics, and using advanced machine learning algorithms, it can largely reduce the developmental and trial process. That's why nearly all the big pharmaceutical and medicine companies are investing on this area. Economics, right? Of course, right? Okay, so just one example from the father of the modern computer science, Alan Turing. Maybe you have heard of Turing machine, right? And some kind of very theoretical stuff about Turing machine properties was originated from Alan Turing, but he has also very applied work in cryptanalysis. So in World War II, Turing and a group of like top mathematicians and engineers in UK, they're trying to crack the codes from the German. Right? So the idea is very interesting, but it's more complex. I just give you some examples. It's like so the code is like you're gonna of course use a lot of different symbols to represent the message, right? It's not like ABC, right? But you can count the frequency. Like for some strange symbols, it might appear like, for example, you might have this symbol, 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 right? You can count their frequencies and look at the histogram. You don't know what exact words they represent, right? But you just find out documents, newspapers, whatever, paragraphs, you count the human words. And you will see some kind of words appear to have like similar frequency of histogram patterns as those unknown codes. Then you can do the mapping. You see, okay, this guy appears to be similar to this one. This might be the, right? This might be Utah, right? This might be Salt Lake City, right? And then your idea is just to map those frequencies smartly, histogram smartly, so that you can get some decoder which map every strange symbol to a word. Of course, it's Dutch word, and then you can decode it into a normal human readable message. Right? It's very interesting, but it's still based upon basic statistical analysis. And machine learning, of course, this is a tool fundamental to machine learning, right? So all machine learning models are essentially building statistical models. And based on data, you do some kind of statistical inference to infer some properties on the line of data. That's machine learning. That's strange, no matter how fancy those words come up, like diffusion models, like foundation models, like large language models, they're all statistical models. Nothing strange. And in some other applications, maybe in algorithm, you often see the randomized algorithms are very cheap, accurate, and also although it cannot guarantee like 100%, it works the best, but in almost all the practical scenarios, it works the best. So that's the power of the randomized algorithms. Right? One table example is called quicksolve. How many have you taken the data structure algorithm design before? Oh, okay, nice, yeah. But anyway, if you haven't heard quicksolve before, that's fine. You just need to know that the quicksolve is just a very, very simple idea. If you want to solve a large set of numbers, right? Every time you just randomly pick up a number and split the set into two parts. One part of numbers are less than that number, and the other part is bigger than that number. You just recursive doing this. And this very simple and very randomized idea works surprisingly well in practice. That's why in practice, people always use quicksort rather than using more elegant and rigorous methods such as like a merge sort, although in theory, they have the same complexity. And also, another example is called the stochastic optimization method. Right? So, how many have you heard of stochastic gradient descent? Oh, okay, it's rare. And never mind, it's fine. Like stochastic optimization, is basically is a fundamental tool for machine learning. So basically, what is machine learning? You have a large amount of data. Then you're going to come out some loss function. Of course, this loss function is justified by probability theory or statistical theory and so on. And then you have to run some optimization to find the best model parameters, right? So optimization is kind of plays a central role. The issue is that people find that those are well designed and has a very good theoretical guarantee. Those determinants optimization in most cases are far worse than very simple stochastic optimization approach. Stochastic optimization means that, okay, every time I just randomly sample a subset of data and then throw them into our objective function and optimize it. Right? And there's a big issue when you take a first look at the stochastic optimization. You find the gradient you compute is totally wrong. But amazingly, if you just keep doing this, it can quickly optimize the loss function to be some very good optimal and give a very good performance. And on the contrary, if you stick to those elegant and the perfect traditional optimization algorithm, it will be very slow and usually is worse than stochastic optimization. That's a very interesting stuff, right? So in my other class, I often told my students that, okay, the traditional optimization algorithms is like, okay, well-trained driver, you just drive toward your house, right? Straightforward, you don't waste you don't detour, right? But stochastic optimization is like a drunk driver. You random drunk north source and the source west, northwest, and so on. Sounds like your head is to fly, right? Just randomly drawing, but eventually you see that you can quickly arrive at your house. Of course, there's some kind of interesting theory behind that, which is not the goal of our class. We just give you an example to show that the randomness is indeed, not just a headache in our real life, but it also can be very useful. Right. And visualization, as we mentioned, like in real world, data is huge. That's why people would like to give some like a good concise visualization to know what is underlying this data. But the data also contains a lot of noises. So right now, a cutting edge topic in scientific visualization domain is try to visualize the uncertainty about data, because you see that data, real world data, you see a lot of missing, a lot of errors, and a lot of noises. So big data analytics, right? So the amount of digital data exploding. So again, no human beings are able to go through all the data. So that comes out, that pushes another domain, another type of techniques. It's called data sketching. Data sketching is like, okay, how can we quickly generate a summary of the data, which has much less amount, but is very indicative, very representative, and is enough to tell us all the properties underlying the data. So why is this important? So here is an interesting example. So how many of you have heard this word? Oh, nice. Oh, great. Yeah, but have you realized how large is this number? Exabyte, right? So it's a 1,000 petabytes, right? So if you want to print out this one exabyte, right, you need this many pages of the standard printed text. And if you cut down one tree, it will approximate enough to print 94,200 pages of a book. I mean, in standard format, it's like the page size is like my iPad. Right? And that means if you want to print out an exabyte of the data, you might need this many trees, right? I'm not gonna read out this number, it's too big for me to read, right? But in 2005, we know on Earth, upper estimate of this trees is this many, right? So that means like even you cut down all of the trees in the Earth, you're not able to print out this 1 exabyte, right? Unfortunately, nowadays our the data we have accumulated so far is far more than 1 exabyte. That's why, of course, we should be concise, right? We should develop such kind of technique to efficiently explore data, efficiently store the data, right? Efficiently explore data. Okay, so last thing I want to emphasize the why the probability and the statistic matters are so important, because it is embedded into the paradigm of scientific research and engineering practice. So scientific, if you carry out scientific research or engineering activities, so this is a basic paradigm. So usually you're gonna make some hypothesis. This is like some kind of like a eureka moment, like you have some like nice idea, suddenly it's like a lightning striking on the head, and you got some nice idea, right? You feel exciting, right? You feel excited, it's so good, it feels like a breakthrough, right? But this is just the step one. You make a hypothesis, you believe you have addressed these problems, like the apple fell into Newton's head, right? It came out the Newton's law, right? But it's not enough. You have to verify your law is correct, right? That then comes the remaining steps, right? You have to gather the data, right? There's another way to say data gathering. This is called doing experiments. Right? You have to do experiments, then you have to analyze your experimental results and to conclude whether these results are effective enough to prove the hypothesis. Right? So one possible example is like in high energy physics. Have you heard of I think there's a Nobel Prize is about gravity wave. Have you heard of that? Okay, so it's about verifying the theory of general relativity, right? So, you know, between any objects in the universe, there's some gravity, right? So this kind of attraction force, right? And according to Einstein's theorem, the whole universe and all the planets and stars, they're sitting on some like field, right? They're moving, they're kind of like affecting the gravitativity field, right? And this fluctuation will incur some waves, but this wave is very, very tiny, right? Is at the level like 10 to minus 13 or 10 to minus 16. This level is very, very small. And so that the scientists have to build up very, very sensitive device to capture those waves, and also to isolate all possible influences and noises. So you can imagine what kind of quality they're going to require about their experimental data and experimental device, right? And also do some statistical analysis, which we will discuss later. It's called hypothesis testing. They have to show that their results must be significant. This many significant, like 5 nines after the point, they can claim, okay, this is a significant result. You can show that, okay, your results are true. It's not some like some false alarms. Okay. So, and I want to mention that the design and running of these experiments and analysis of results are all based on statistics and probability. That's why, I mean, in the future, if any of you would like to go to graduate school or even do some PhD program, you will know that. I mean, in a more concrete sense. Yeah. And in data science, like as we mentioned, want to process and squash enormous valuable data. I want to mine working data, want to analyze results and draw conclusions. And every step is subject to noise and involves statistics, right? So anyway, so this is just a set of examples. I want to like everyone to feel, okay, this class is important and it's very useful for your future study or career development. And we would like you guys to spend some time, check out our class web page and download the book and start reading chapter 1 when available. Okay, thank you, and we'll see you on Thursday.